Hey everybody, it's Silvershroom and welcome back to the Blender Solar System. Last time we put together the planet's orbits and now we're going to assemble the planetary systems. And for the rest of the series I'm going to less be explaining it step by step and kind of just explain the new methods and mechanics as I come to them. So to start off here, I've gone ahead and pasted the orbits of the 4 terrestrial planets. And I'll use Alt-R and Clear Delta to reset their rotations. And I'll put these inside their proper collections to be used for later. Now, for Mercury's orbit, I'm going to do something similar to what I did in the solar system file, with the longitude of the ascending node, the argument of the periapsis, and I'll add 180 to turn it around, because the effect we're trying to do is the motion of the sun from a vantage point centered on the planet, and the orbit's not going to be inclined because the x and y plane is going to be the orbital plane of each respective planet. So I have this point light that represents the sun. Make it follow the path, and it'll appear to orbit around Mercury. And you can see the effect it has when it's rendered. But Mercury, of course, rotates. Before we can make it rotate, we need to orient it correctly, and just like with the sun, we're going to take the right ascension of its north pole, then its axial tilt, which in Mercury's case is practically nothing. But it's there anyway. Then, with the driver, I use rotate from the script I wrote, and Mercury's rotation period, just under 59 days. And I'll go ahead and give you a glimpse of the script. I have rotate in orbit, and we'll talk about the parameters for the orbit script later. So Mercury is all done. With Venus, it's going to be pretty much the same. Except Venus's axial tilt is extremely high to indicate its retrograde rotation. So when I do rotate, 243 days, it will rotate clockwise. And that's that. Now for Earth, it's going to start out the same. But before I make it rotate, there's something else I want to do first. Because as 0 is meant to be noon on the prime meridian on January 1st, 2000, I want the prime meridian to be facing the sun at this point in time. In order to do that, I'm going to take Earth's mean anomaly at the time which should make one of its axes point directly at the sun. Then I'll rotate it another 90, and there we go. All I do now is rotate. A rotation period of just under a day. And that should translate to a solar day of 24 hours, so the prime meridian should always be facing the sun with the increments of 1 day per frame. So that takes care of the Earth itself, but Earth, it just so happens that Earth has a natural satellite, the Moon. Now, instead of just making an orbit for the Moon, I'm going to start by making an empty object. That'll represent the Laplace plane. And parent the orbit to it. First, I need to change the orbit's direction. And scale the orbit to the proper size. Not particularly eccentric. Wait. There we go. And what the Laplace plane is the plane around which the orbital nodes rotate. So the point at which an inclined orbit passes through the plane of reference tends to change over time, and that is what this empty object is going to help us represent. So with this, we first want to change it to the longitude of ascending node at the proper point in time. And then with the orbit itself, I'm going to incline it. And then the argument of perigee. And now with this empty object, I'm going to have it follow this path. And the Moon is set to copy its location. Now you can see if I rotate this, that's how to make the orbital nodes precess around the plane. So I want this to rotate with a period of 18.6 years. Now the rotation is actually going to be in the opposite direction of the orbit, so I want to do negative 6.8 times the number of days in a year, 365.25. You can see it's going to rotate clockwise very slowly, and this many days in, it should come full circle. But that's not all, because the longitude of the periapsis changes too. In the Moon's case, over a period of just under 6 years, and this is actually going to be in the same direction that it orbits, so this is going to be positive. And that will rotate as well. that out of the way, it's time to take care of the moon itself. Now, the moon is tidally locked to Earth, so it always shows the same face. This face, to be exact, so I want to make it so the moon's y-axis points toward Earth. But before I do that, I want to get its axial tilt right. So this isn't going to be perfect, but try to get it as good as I can. But the axial tilt I have is relative to the orbit, so I actually wanted to copy the rotation of its orbit. Then hit this to disable the modifier without changing the rotation, and for some reason it changed the location values too without it actually moving it. I'll just clear that. Alt G. By these rotations to deltas. Now I want the x-axis to face the right way. This is a really complicated process. To do that, I should just be able to put in the longitude of ascending node and argument of periapsis negative. And now I should be able to properly do its axial tilt. And there we go. But now I also want to make it orbit, so like before, I do orbit with the orbital period, the eccentricity, and the mean anomaly. However, there are two more parameters to use, and that is the nodal precession period and the periapsis precession periods I used before. And what that'll do is account for the changes in the orientation of the moon's orbit, so that the moon's sidereal orbital period, which is the value often given, ends with the moon back on the same side of the Earth. And now that it has the proper mean anomaly, I can mess with them, put in these other values I already used to try and get an axis of the moon to face the Earth. And a negative 90 degrees should do it. And there we have the near side facing the Earth, and it is in a waning crescent phase. Now what we have to do is make the moon rotate with the same as its orbital period. And that'll do it. But we're still not done yet, because the moon is so large in comparison to the Earth that the Earth and the moon orbit a common barycenter that, while still inside the Earth, is quite a ways away from its surface, from its center, I mean. Now, the value often given for the moon's distance from the Earth is actually the moon's distance from the Earth, and not from the Earth-Moon barycenter. The moon is closer to the barycenter than it is to the Earth itself. So I can just scale it down slightly with a calculated value for that ratio. And I'll just apply scale. Now, in order to make the Earth wobble around that barycenter, I'm going to make the Earth, just like the moon, copy the location of that empty moon object, but not all the way. I'm going to invert it so it's opposite, and scale this influence down to another calculated value. Now you can see that as the moon orbits, the Earth will also wobble around that barycenter. So, pretty complicated, but once you figure out these kinds of algorithms, it's more tedious than anything. But I can get the job done. Now, with Mars and its moons, it's going to be basically more of the same thing, so I probably won't be talking much. But I won't be dealing with the barycenter since Mars's moons are so tiny, they have hardly any influence on Mars's position. Okay, now the values for Phobos and Deimos' orbits are given with respect to Mars's equator, so I'm gonna need to copy that rotation. And I believe the longitudes of the ascending node are measured from where Mars's equatorial plane crosses its orbital plane. I'm not entirely sure, but this should work. So I'm gonna need to rotate them both by another 90 degrees. Oh, forgot one more thing. Because the Laplace planes are also tilted slightly from Mars's equator, so we need to take care of that as well. Okay, so like with the moon, gotta get their equators level with their orbits. Then, once I put in the mean anomaly, one of the axes should face Mars. Oh, gotta get it clear exactly which axis should be facing Mars. And that should be right. This one. Now, just rotate, and we're good for Phobos. Now we gotta do is take care of Deimos. And that should be it. Just slow things down a bit, you can see them orbit. And that's all. All 4 terrestrial planet systems complete. So, next time on the Blender Solar System, we're going to move on to putting together even more planetary systems. See you then.